Okay, so the function that we're given is modeling S. S is measured in meters, so it looks like the function S is modeling where the train is on some sort of axis, because it says here moving left or moving, obviously the other option is moving right. So the function S of t could tell us that the train is negative 100 meters to the left, or it could say it's 1,000 meters to the right of the starting position. That's what S of t is modeling. Okay, so we're asked to find out where on what intervals is the train moving to the left. So this is a location function. You plug in a value for t and it spits out where it is in terms of meters, to the left or to the right. We need something about the train moving. We need something about the motion of the train. So we need velocity of the train, which is the first derivative of the location function. So if we evaluate the derivative here using the power rule, the 3 comes down, cancels out nicely with that 3 in the denominator, and then it gets reduced by 1. The 2 comes down and multiplies, and then it gets reduced by 1. And then the derivative of 30t is just 30. And the derivative of a constant of 1 is just nothing. So we found our derivative. We're asked to find out when it's moving to the left. So we're assuming to the right is, I guess they should specify that, huh? Entering one, no, they don't specify. So we're going to assume that moving to the left means negative velocity, going backwards. Because on a number line, when you go to the right, you're getting bigger, going more positive. So to find out where it's moving to the left, we want to find out when this quadratic crosses the x-axis, right? It's going to make a U shape because this is positive. This will be a rough sketch of what the quadratic looks like. So we want to find out where it crosses the x-axis, and then we can easily identify the intervals for which it's negative. So to find out where it crosses the x-axis, we're going to plug in 0 for s prime of t, 0 for the velocity. And then we'll solve this like a regular quadratic equation. That will tell us when it's neither moving to the left nor the right. It's perfectly still. So factor out a 2. And then that's nice and easy to factor because a is 1. 2 numbers are multiplied to be 15, but add up to be negative 8. Negative 3 and negative 5, right? So t minus 5 and t minus 3. So if you solve that, t is going to be 5 and 3 because you set each factor piece equal to 0. If you plug in 5, this whole right side equals 0. So because we know something about the quadratic, we know between 5 and 3. Interval notation, so I'm going to say 3, 5 with parentheses because they want the interval where the train is moving left. It's neither moving left nor right if we were to be exactly 3, so it's got to be parentheses there. And the reason why I'm able to be assured that it's between these two and not to the left of 3 and to the right of 5 is because I know something about how quadratics work. Right? Otherwise, if you're not sure, just plug in some numbers to test. If you solve for where a function equals 0, you're finding out the places where it crosses the x-axis, and if it's a continuous function, it's not gonna, it's gonna keep repeating a behavior after that. So, long and short is you just want to test a point in between if you wanted to be sure. If you plug in 4 into the velocity function, not the original function, because that would just tell you what location you're at when you at 4. If you plug that into the velocity function, 4 squared is 16. 16 times 4 is 64. We're negative. We're going backwards. We're going to the left. So that assures us that between here, we're getting negative numbers. And if you plug in a number to the left of 3, we should be getting something positive if we've analyzed that quadratic correctly. And if you plug in 0, you get out positive 30. And if you plug in like 100, something to the right of 5, then you're going to get a really huge number. Oh, actually, we should check just to make sure. Just to reassure ourselves. Definitely positive, right? Very, very positive velocity. So between here, the velocity is negative, so we're moving to the left. So that is our interval. This question is asking me about velocity. So I know I need to take a derivative of the positional function. And they want the velocity of the ball when it first reaches a vertical height of 880 feet. So that means we want to plug in 800. Oh wait. Oh, sorry. No, t is time. When it first reaches a vertical height of 880 feet. So s of t tells us the height of the ball. We need to plug 880 in for s of t so we can find the time when it's reached 880 feet. It'll reach it. And another good thing to keep in mind is that it'll reach that height twice, right? 256 times 880. Oh, no, t. Getting ahead of I'm not even getting ahead of myself, doing it wrong there. 880 goes in for the height. Now we're trying to solve for what that time location is. It's quadratic, so let's set it equal to 0. And let's factor out negative 16 from everything to make the leading coefficient positive. So I'm going to remember I'm dividing, that's a t there, dividing everything by negative 16, so that's going to switch all the signs. So that's negative, oops, negative 16. Oh my gosh, I have a new mouse and it's not working out well. Minus 16t, and then this is going to be plus 80 divided by 16, that makes 55. So lucky guess that 16 was going to fit into 880. And now that's something I can factor. So two numbers that multiply would be 55, that have to be negative 16. Actually, I hope it's something I can factor. How about negative 11, negative 5? So it's multiplied to be positive 55, but they add up to be negative 16. So we got two locations, t equals 5 and t equals 11. Those are the two places where we reach a vertical height of 808 feet. But they said when it first reaches the vertical height. So that's the time we want. So that's what we have to plug in here. It reaches 880 feet at 5 seconds after launch. So if they want to know the velocity, we just have to plug in 5 seconds into the velocity function. 32 times 5, that's negative because it's negative 32. So it looks like 96 feet per second is our velocity.